Right, so today we're going to kind of pick up where we left off yesterday looking at complex numbers in trig form. We learned a very efficient way yesterday to multiply and divide complex numbers using trig form. Today we're going to learn a way to raise complex numbers to powers and to take roots. Okay, so those are the two operations we're going to look at today with complex numbers. The reason why raising a number to a power can be time consuming is, imagine you had something like, let's just say 3 plus 2i to the 8th power. Okay, to do that out, that means I would have to write 3 plus 2i 8 times, okay? And then I would have to FOIL all 8 pairs of parentheses, okay? There'd be tons of multiplications, tons of combining like terms. Chances of making a mistake doing something like this are pretty high. Even worse, if I asked you to do something to the 80th power, now you'd have to write 80 sets of parentheses, and it's almost impossible to not make a mistake. Well, if we do this in trig form, it doesn't matter if you ask me to raise it to the 8th power, the 80th power, or the 800th power. I can do any of them just as fast with a calculator. Makes no difference. All right? So that's why we're going to learn how to do this in trig form. Okay, we're not going to do a proof of the theorem, but what we're going to do is look at one specific example, which is squaring. And then I think you guys will see a pattern, and we'll generalize that pattern to cubing, 4th power, 5th power, any power we want. All right, so I want to square this number. And again, it's just a generic number. I don't know r and I don't know theta. In an actual problem, you would know them. Okay, but I want to square that. Okay, so I'm just going to write r cosine theta, I sine theta, times itself. R cosine theta, I sine theta. All right, now the first part is pretty straightforward to do out. I have an r in the first part and an r in the second part. What's r times r? R squared. So I'm going to start with that. And now you can ignore this r. We've already done r times r, so we can pretend like the r's aren't there. What's left is cosine theta plus I sine theta, cosine theta plus I sine theta. That we have to FOIL out. Okay, so let's start with, what's cosine times cosine? So we have cosine squared theta. And now we have cosine I sine, cosine I sine. We have two of them, two of the cosine I sines. So plus, I'm going to write it like this. You can write 2i or I2. You're going to see why I'm writing the I first in a second. But it doesn't really matter. So 2 of the cosine I sine. And since it's all multiplied, you can put it in any order. 2 of the cosine I sines.
Is that a multiplication right there? Sine?
Yes, that's multiplication. And the reason I wrote it as 2 sine, cosine in that particular order is because it's going to look similar to something we did back in section 7.5. You're going to recognize this, I hope. All right, and then the last part, we have I sine times I sine. That's going to be minus, not minus I sine squared, just minus sine squared. Okay, you'd have sine times sine, which is sine squared. I times I is -1. So minus sine squared. Now I'm going to regroup it so that I can put a couple things next to each other, and then I'm hoping from there you see an identity. All right, so we've got r squared. I'm just going to take minus sine squared and move it next to cosine squared. Cosine squared minus sine squared. Okay, not to be confused with cosine squared plus sine squared, which that's a Pythagorean identity, but that's not what we have here. Minus, that's a big difference. Okay, but it still is something else. Plus I, 2 sine theta cosine theta. Let's take a look at this first part. Cosine squared theta minus sine squared theta. Okay, I'm going to bring up an identity or a few identities from section 7.5. Does anybody recognize what cosine squared theta minus sine squared theta is? Cosine 2 theta. Okay, so that whole thing simplifies just to cosine 2 theta. All right, so we got r squared cosine 2 theta plus I. Now let's look at that last part, 2 sine cosine. Okay. Does anybody recognize what 2 sine cosine is? Sine 2 theta. And that's why I wrote it in the order I did, so you'd recognize it. Okay. 2 sine cosine is sine 2 theta. All right, so now I'm hoping you can look at that and see a pattern from what we started with and what we finished with, and we squared it. Okay, you can kind of see maybe that squaring popped up in a few different spots. So based on that, anybody think they could tell me what they think z cubed would be? R cubed.
Cosine of 3 theta.
Cosine 3 theta. Yeah.
I sine 3 theta.
I sine 3 theta. Right. So now, if you wanted me to raise z to the 50th power, I'd just say it's r to the 50th, cosine 50 theta plus I sine 50 theta. It's very easy to raise a number to a power doing it this way. Right?
That's all you have to do.
That's all you have to do. Okay, and that is called de Moivre's theorem. Okay, that's how you say that, de Moivre's theorem. Right, so if you want to take any number in trig form, okay, that's the key. It has to be in trig form. Raise it to a power. Take the radius, raise it to the power. Take the angle and multiply it by the power. Okay, those are the 2 steps. Raise the radius to the power, multiply the angle by the power. And now, with this, we don't have to write out 30 sets of parentheses and do all the foiling. Okay, pretty much going to be able to do these in your head. Okay, most of the time. All right. So the first example I'm going to give you, it's just cubing something. So there's a question, should we just do this the old way? 1 plus root 3i cubed? I would say if you're cubing, it might be just as fast to do it the old way. But if you're starting to do anything to like the 5th, 6th, 10th power, it's going to be faster to do it the new way. All right. What's wrong with this problem that I can't use de Moivre's theorem on it right away? It's not in the right format. This is standard form. What form do I have to get it in?
Get it into
Trig form. Okay. So that's the first step. I got to get this into trig form with the sine and cosines. Okay. In trig form, I need 2 things, r and theta. Right. So if we were to sketch this, we've gone right 1, up root 3. So this is 1. That's root 3. What would my radius be there? Yeah, it would be 2. If you square the bottom, you get 1. Square the height, you get 3. 1 plus 3 is 4. take the square root. My radius is 2. And so we just did the Pythagorean theorem to get the radius.
Is this a 30, 60, 90?
Well, let's find the angle and see what happens. All right, if you recognize something like that, that could speed things up. If not, we just use the formula for theta. What's my formula to find theta in quadrant 1? It's also the same in quadrant 4.
Tangent.
Inverse, yeah. Of
3 divided by 1, or 1 divided by
y over x. So the vertical over the horizontal. Right, so really it's just the inverse tangent of square root 3. My suggestion is always do it in degrees first, and usually you'll recognize a nice answer, and then if you need to, change to radians after. Because if you get some number up here that has something to do with pi, like 1.57, most people aren't going to recognize that as pi over 2. But I bet most people would recognize 90, because it'll be a nice answer. All right? So do it in degrees first, change to radians after if you need to. All right. So I get a nice answer. If I had done this in radians, I would have gotten some decimal that in reality is a nice answer, but I wouldn't have recognized it. I get 60 degrees. Right, so now my point becomes 2 cosine 60 plus I sine 60. And what power am I going to raise that to?
3.
Third power. That's probably the longest part of the problem, changing it to trig form. Now, if I cube it, what does my radius become? 8, 2 cubed. And what does my angle become? 180. That's it. So we just cubed that complex number. Now, whenever your angles are multiples of 90, angles that are multiples of 90 have very nice answers if we do it out, like zeros, ones, and negative ones. All right, so this time, only because I got answers that are multiples of 90 for my angle, I'm going to rewrite this back in the regular form. Okay, I'm going to write it back in standard form. Okay, this line that we have right here, that's the answer in trig form. Okay? And if that's what they want, that's fine. But let's do this one out in standard form. So you're going to take the 8 and distribute it out. So you have 8 cosine 180 plus 8 sine 180. And that's going to be the imaginary part. Okay, let's just type in and see what we get. If you want to visualize the graph, you can. But to save time, I'm just going to type in 8 cosine 180 and see what I get. Negative 8. Negative 8 plus, now let's do 8 sine 180.
So you don't put the I in?
0. In this case, no, I don't, because it's going to be 0. All right. If, I mean, I can put it in like that.
I mean, like when you're putting in a calculator, like.
No, the I is just something that's tacked on to the end.
All right.
Yep. And in this case, since it's 0i, do I need to write it?
No.
No. So the answer is really just negative 8. Okay, we're not always going to change it from trig form back to standard. Unless the angles are multiples of 90, we'll get very nice answers. Okay. Any question on what we did there?
And what are you going to usually have us do? Is it standard or trig form?
There'll be a mixture of both.
Both.
Yep. There'll be a mixture. Some things will be standard and some will be trig form. But the directions will be very clear on the test. Yep. In fact, most of the test is multiple choice. So if you got this for a test, on the test, this step, and I had this listed as an answer, then you know you have to change it to standard form. Okay. Standard form does not have the sines and cosines. All right. This is one that we definitely would not want to do out to the 8th power. Okay, so I'm going to change it to trig form, and then it's going to be very, very quick to do out. All right, let's find our radius first. So we're going to square x, and then we're going to square y. We're going to get the same thing when we square both parts. Anyone tell me what you get when you square this fraction? Root 2 over 2? Well, off to the side, what do you get when you square the top? 2. What do you get when you square the bottom?
1/2.
So we get 1/2. And the negative, when you square it, goes away. So we get 1/2 plus, what's root 2 over 2 squared? 1/2 again. So we squared them. And now take the square root of 1/2 plus 1/2. 1. Okay, so my radius is 1. And I still need to get my angle. What quadrant am I in this time?
2.
Yep, left and up. So I'm somewhere in quadrant 2. What's my formula from yesterday to find theta in quadrant 2?
Pi plus tangent, inverse tangent, y over x.
Yeah, if we're going to do radians, you could do pi plus. If I'm going to do degrees, yeah, it would be 180 plus. Could do it either way. Inverse tangent of y over x. Now, y and x are the same, except one of them's negative. So what do you get when you divide y by x? Negative 1. Okay, since y and x are the same fraction, you're dividing two things that are the same, except one of them's negative. Okay, so negative 1. Okay, if you do that out in your calculator, you're going to get negative 45. Okay, which means my angle is how much? 135. I guarantee that's the longest part of the problem, putting this in trig form. Raising it to the 8th power, it's going to be a piece of cake.
Where do we get the 2 divided by 4?
If you
Why do we need it then?
Because we got to do the Pythagorean theorem to find
Just to figure out the sector or whatever.
that radius. Remember, these are two sides of a triangle. This side is root 2 over 2, and this side is root 2 over 2. So you square the bottom, square the height, add them up and take the square root. Okay. Any questions on doing the Pythagorean theorem to get r there? All right. So now, let's write our number in trig form. Okay. What's my radius?
1.
Just 1, so I don't even really need it. You can put it if you want. 1 cosine 135. I sine 135. And what power am I raising that all to?
8.
8th. Well, not much is going to happen with the radius. What's 1 to the 8th power? 1. So my radius is still 1. And what do I do with 135 and 8 to get my new angle? Yeah, just multiply 135 times 8. Okay, that's 1080. Now, earlier, I think when we were going over homework, I mentioned sometimes you could get an angle that's really big, and there's a way to make it smaller. You can minus 360 from that, and in general, I don't think you'd ever see an answer listed with an angle that big. They're going to minus 360 until the angle is between 0 and 360. So we might have to do it a couple times. Once, twice. Can I do it again? Oh. So really, 1080 is the same as 0 degrees. Cosine 0 plus I sine 0. And 0 is a multiple of 90. So we're going to get very nice answers if we change it. Okay. Does anybody remember cosine of 0? All right. So yeah, Upi just told us that the cosine of 0 is 1. Does anybody remember the sine of 0?
Give me 2 seconds. 0.
0. So I times 0, what happens to that part?
Cancel that.
That's gone. We have 1 times 1. So 1 times 1?
1.
Okay, so again, anytime your answer here is a 0, 90, 180, or 270, they're probably going to change to standard form because you get a nice answer. Okay, any questions on them? All right. Now, thinking back to that first example that we did, okay, we cubed something in example 1. What's the reverse of cubing? How do you go backwards from? Not a negative here, but it's, yeah. Yeah, it's a cube root, okay? So how would we reverse what we did? We would take a cube root. Right? So what we're going to start to look at now is roots. Okay, roots are pretty complicated to do if you do them in standard form, or can be. I think trig form gives you a very systematic way to do it. It's not the easiest process when you're looking at it at first, but once you do a couple examples, the process never changes. It's the same every time. You just have to figure out what are the steps I follow. All right? So I'm just going to go back for a second and look at example 1. All right. So if you cube 1 plus root 3i, you get negative 8. So what would you get if you take the cube root of negative 8?
How do we take the cube root of negative?
Well, we're going to learn how to do that. But based on this example, we should already know what the answer would be. Right. If you cube 1 plus root 3i and get negative 8, then if you cube root negative 8, you'd go back to what you started with. All right? So this is one of the answers for the cube root of negative 8. Anybody have a guess how many answers there are for a cube root? 3. Square root would be 2. Yeah, there's always as many answers as there are the root you're looking for. So if I asked you to do a 5th root problem, you'd find 5 answers for me. All right? So I just want everyone to see that idea. If you cube 1 plus root 3i, you get negative 8. So if you cube root negative 8, that's one of the 3 answers. Okay? So that's what we're going to look at. How do we cube root negative 8? So that's what I just told you guys. All right, so how do we find roots? Okay, and it can be any root. It can be a square root, cube root, 5th root, 12th root. Generally on the test, I'm not going to have you go much higher than like a 4th root. Okay, that's sufficient that I can see you know what you're doing, but it's not overly complicated like finding 15 answers. Okay. All right, so first thing we have to do is set up this equation. Okay, z to the n equals a. And it's important to remember here that z and a are in the set of complex numbers. We're not just dealing with real numbers. We are dealing with complex numbers. So for example, if I were to pick like a basic problem from like pre-algebra, and I said to you, I want you to find the square roots of 9. Find the square root of 9. This is the equation you would set up to do that. Z squared equals 9. If you can solve this equation, then you can tell me what the square roots of 9 are. So you take the square root of each side, and you get 3 and negative 3. All right, so the power or the root that you're taking goes here. Square root, whatever it is, and this is what you're taking the root of. Okay, if I wanted you to find the cube root of 27, this is the equation you would set up. Z cubed equals 27. Something cubed is 27. You have to figure out what do you cube to get 27. And the answer here would be
3.
3. Right? The only difference the way we're setting it up is this and that are not going to be real numbers all of the time. They're going to be complex numbers. All right, so step one is to rewrite this in trig form. Okay, z to the n equals a. We don't do much with the n. The n is just what you're taking the root of. That'll just be a number, a 2, a 3, a 4, or 5, something like that. What's on the right, you're going to have numbers for. Okay? Right now, I've written everything as variables. Bless you.
Thank you.
But in a real problem, you are going to know R1 and you are going to know theta 1. And if you don't know them, you're going to be able to figure them out. Okay? A is what you're taking the root of. Z, you are not going to know. Okay, so when we write z in trig form, we're just going to have to write it pretty much exactly like that, with an r and a theta. The r's and the thetas in z, that's what we're going to solve for. Right, so now, at step, I'm going to rewrite the equation I had up above. Plugging that in for A. And I'm going to plug in what I have in the bottom for Z. So that's my next step. Just rewrite that whole thing, plugging in where I showed you with the arrows. All right. So now we have, instead of Z, I've got R2 cosine theta 2 plus I sine theta 2. And that's to the nth power. Again, the n just stayed the same. And on the other side, I don't have A anymore. I have A in trig form. R1 cosine theta 1 plus I sine theta 1. And it's going to be easier when we do an example, because this whole right side is going to be numbers. Right? There will be no letters on the right. There will be letters on the left. N will not be a letter. That'll be an integer, like 2, 3, 4, 5, something like that. Okay, so at this step, the only letters you're going to have are here, here, and here. And now we need to do out what's on the left. Okay, this is de Moivre's theorem. Okay, how would I rewrite the left-hand side doing out this power? All right, we are going to multiply the n by something, but let's start with the radius first. What do we do with that and the power? Brendan?
R2 to the n?
Yeah, it's R2 to the n. Okay, so whatever the power is, raise R2 to the nth power. And then what do we do with the angle and the power? Multiply. So it's going to be cosine n theta 2. Everything else is going to stay the same. Cosine n theta 2, I sine n theta 2. Right-hand side, just copy down from up above. All right. Now, at this point, we have an equation. The equation on the left has a radius, and it has an angle. The equation on the right is going to have a radius, and it's going to have an angle. In order for what's on the left to match what's on the right, the radius on the left has to equal the radius on the right. If they don't, then we wouldn't be able to put an equal sign between them. Okay? So radius on the left has to match the radius on the right. Okay? And not only do the two radii have to match, what else do you think has to match?
Cosine and sine.
What about the cosine and sine?
They have to be, and they have to.
What about them though? Yeah?
Do thetas have to match?
Yeah, the angles. And this angle has to be equal to this angle. So n theta 2 has to equal theta 1. Or, remember I said earlier, you're going to get multiple answers. If you're doing a cube root, you're going to get 3 answers. If you're doing a square root, you're going to get 2 answers. So n theta 2 just doesn't have to equal this angle. But what can you add to an angle that doesn't change it? You can add 360, or in radians,
2 pi.
2 pi. So n theta 2 could equal theta 1 plus any multiple of 2 pi. Okay? So any multiple of 2 pi. Or 360 if you're doing it in degrees. All right, so I think the template here, it's a little confusing to look at, but the bottom line is you're going to be solving two equations when you're done. The one on the left and the one on the right. Okay? And that's going to give us our answers. Now, k, I didn't say much about, what's k? Well, remember when we solved trig functions and we put like plus 2 pi k on the end of an answer? Remember doing that? K was always an integer. And that's what it is here. Okay? K is an integer. And by letting k be different integers, that's how we're going to get different answers for the angle. Okay? You're always going to have one answer for the radius. Whatever, if you get a radius of 2, that's the radius for every answer in your problem. But you're going to get different answers for the angle. And how many answers you get depends on what route you take. The nice part is it's easy to remember how many answers you get. If you take a 5th route, you get 5. 6th route, you get 6. 4th route, you get 4. So an nth route has n answers. Okay, that's what I just said. And the way you find all the answers is you're going to let k equal different integers. For example, if you wanted to find the cube roots, how many answers did I say cube root has?
3.
3. You would let k equal 0, 1, and 2. That's how you get the 3 answers. Okay? How about a 4th root?
0, 2, 3.
You would let k equal 0, 1, 2, 3. That's how you get the 4 answers. So we just have to remember when we fill in for k, we start with 0, and we go right up to, it's basically 1 less than the root. 5th root, you'd go 0, 1, 2, 3, 4. Right, and another thing that's kind of just interesting about the answers is once you get all your different answers, if you were to draw them on paper, they're all equally spaced. Okay? They're all nicely spaced on a circle. So for example, if you were finding cube roots, you would get 3 answers. And they might look something like this. 1 here, 1 here, 1 here. They're all equally spaced. If you were finding 4th roots, okay, they might look something like this. 1 here, 1 here, 1 here, and 1 here. They're all nicely spaced on a circle. So just a pattern that ends up coming up. And there's one other word I have to explain that the book might use. They might ask you to find what's called roots of unity. Does anybody have a guess what number that they're talking about if they say the word unity?
2.
Not 2.
4.
No, not 4. Think of like almost connected to Spanish. Like what's does anybody know the word for 1 in Spanish?
Uno.
Right? Uno, UN. Unity starts with a UN. So I don't know if that really helps, but if they ask you to find roots of unity, basically that just means find the roots of 1. Find the square root of 1, find the cube root of 1, things like that. So if you see directions with the word unity and you don't like the word unity, basic point is cross it out and write the word 1. On the test, I'm going to write the word 1. Okay, but if you see it in the book, I just want you to know unity means 1. All right, so now for the time we have left, we'll practice going through some examples. I've got like 4 different examples to look at. I don't think we'll get through them all, but we can do as many as we have time for. All right. find and graph the fourth roots of 1. Okay, I've already set up the equation for you. That is step 1. Write z, fill in your power, and fill in 1. How many answers am I expecting here? I'm expecting 4 answers when I'm done. All right, so first thing I have to do is rewrite this in trig form. Okay, for z, I don't know z. This is what you're going to write for z every time. R cosine theta plus I sine theta. Every single problem you do a root on, just change z to that every time. Now the right-hand side, it depends. Okay? We need to change this number to trig form. It's 1, but what's the imaginary part if they don't write it? 0i. Okay? I'm going to draw that, and I need to find 2 things, my radius and my angle. How would I sketch 1 plus 0i?
You go 1 to the right and then 0.
Yeah, just 1 to the right. Now, since I stayed right on the axis, we shouldn't need Pythagorean theorem to find the distance from the origin to that point. What's the radius here? 1. And what's my angle?
0.
So what is it?
It's 0 because you're not.
Yeah, it's 0 because I didn't move off the positive x-axis. Yeah. So my radius is 1, my angle is 0. Okay. Now write that down on the right-hand side in trig form. Okay. What you're filling in for right now is r1 and theta 1. Okay. r1 is 1, theta 1 is 0. So 1 cosine 0 plus I sine 0. Okay, before we can set up our equation, there's one thing we have to do out on the left-hand side. How do I do out r cosine theta plus I sine theta to the 4th?
Make it like r to the 4.
Yeah, r to the 4th cosine
4 theta.
4 theta. Some people do this step in their head and they don't even write the first step. Okay, if you want to write it, that's fine. 1 cosine 0, I sine 0. All right, now we're ready to set up our equations and solve. That has to match that. Okay, my radius on the left has to match my radius on the right. Okay, so write that down. R to the 4th equals 1. All right, and now the way you get rid of this exponent, or one way to think about it, is you have to raise each side to a power that would cancel out a 4. And when you raise a power to a power, you multiply. So what number can you multiply by 4 and it cancels it out? 1/4. Yeah. If some of you were thinking take the 4th root of each side, that's the same thing. That's what I just did. All right. So those cancel out. I'm left with r. If you need to, you can type that in on your calculator. But 1 to any power is what? 1. Okay, so I have my radius. Okay, next thing I have to do is find my angle. So this has to equal that. So 4 theta equals 0. But what did I say we could add?
360 or 2 pi.
You could do 360 or 2 pi. Let's just do it in degrees.
Do you care if you do it in radians?
No, I would always do it in degrees, and then if the answers are listed in radians, just convert degrees to radians. Just by multiplying by pi and divide by 180. You could just change degrees to radians.
Isn't r always supposed to be outside the parentheses?
Isn't r...
Like your the first, when you first wrote the equation.
Oh, yeah, thank you. Yeah, that's kind of a technical thing, but that is important. R is usually outside the parenthesis. Everything we did, though, is correct. I wrote it outside on the second step. Thank you. All right, and now how do I get theta by itself? How do I move this 4 over? Divide by 4 here, here, and here. Okay, so that's gone. And now I'm going to have a formula for what the angles are. 0 divided by 4 is just 0. So theta equals 90k. And what are the 4 values we're going to let k be?
0, 2, 3.
0, 1, 2, 3. Right. So now that's the hard part. We've done all the hard work. Now we just have to write our answer. Every answer is going to have a radius of 1. Cosine, 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 cosine. And now let's get our first angle. Fill in 0. What's 90 times 0? 0. There's my first answer. Second answer. Fill in 1 for k. What's 90 times 1? 90. Okay. Third answer. Fill in 2 for k. What's 90 times 2? 180. And fourth answer. 90 times 3, 270. Now, because these answers are multiples of 90, you could change them, and you would get very nice answers for all of them. Every one of these sines and cosines is either a 1, a -1, or a 0. Okay, I'm not going to go through changing them all to standard form. I'm going to leave them in trig form. Okay, any questions on that one? All right, it takes a little bit of getting used to, but once you get it, it's not too bad. Let's try. These are the last two. Let's try this one. Okay, cube roots of -8. Okay, I'm going to help you guys with the equation. It would be z cubed. Start with that, and what would go on the other side? -8. Now, if this right-hand side was already in trig form, that's great. That's one less thing I have to do. But if it's not in trig form, I have to find the radius and find the angle. Okay, for z, fill in what we always do. And I'm going to do something else at the same time. R cubed cosine 3 theta. I sine 3 theta. Any questions on what I did on the left? I changed z to trig form, and I did Wolves Theorem at the same time. Now, -8. How would you graph -8?
Down.
Left. All right, left 8. Remember, down is imaginary. That's real. That's imaginary. So if we go left 8, what's my radius? 8. And what's my angle? 0 would be if you were on the right. 180. Now, write that down, and it's going to be the same from here. 8 cosine 180 plus I sine 180. What does r cubed have to equal?
2.
Well, yes, r is going to be 2,
8.
but r cubed equals 8. And Brendan already figured out what number do you cube to get 8? 2. So in all 3 answers to this problem, that's your radius. Somebody give me my equation for my angle. 180. 360k. And now, how do we get theta by itself? Divided by 3, 3, 3. What's 180 divided by 3? 60. And 360 divided by 3? 120. What are the 3 values you're going to let k be? 0, 1, 2. Yep. Now we write our answers. What's my radius in all three answers? 2, 2, 2. Put your parentheses the right way. Okay, now let's get our first angle. Fill in 0 for k. What's 120 times 0?
0.
Plus 60.
60.
60. All right, second answer, fill in 1. What's 120 times 1?
120.
120 plus 60? 180. Get our third answer, fill in 2 for k. What's 120 times 2? 240 plus 60? 300. So it's really not too bad. I mean, it is a pretty decent process to follow, but it's not too bad once you understand it. Okay, we had one more to do. I'm gonna hold off because we only have about 4 minutes left. If you want to see how to do this one, it's in my video for the honor section that I had taught last week. But we can go over something like this tomorrow in class if we need to. It's the same steps. Just the only thing here is, what's the imaginary part?
1.
And the real part?
1.
1. So you guys could probably already figure out, if you go right 1 and up 1, what kind of angle does that make?
45.
Yeah, it's a 45. And my radius? Oh, I think we did this earlier. Yeah. And now you do the same problem we just did from there. Okay? So if you want to try that one on your own and then look it up in the video or ask me about it, we can do it tomorrow. Otherwise, I think tomorrow you'll find it is a pretty easy lesson. Much easier than today. All right, and how many answers would you expect here? 5, yeah. All right, so the homework, just a few problems. 3 through 5, 8 through 12, 26 through 28, and 35. Okay, and that's on page 458. All right, so that finishes up everything that we're going to do with complex numbers in trig form. Tomorrow we'll take a look at vectors.